Okay, now is screen visible?
Yes, sir.
Okay, so now we want to state the sequential criteria for continuity. So now you know sequential criteria for limits. So what could be sequential criteria for continuity? Right. So suppose f is defined on A, right? C belongs to A, then f is continuous at C if and only if. If and only if what? What I should say now? Yes.
So for any sequence xn in A, if a
Uh,
limit of xn is equal to c, then limit of f of xn is equal to f of c.
right. For any sequence xn in A with limit of xn is C, the sequence f of xn converges to f of c. But here we expect the limit is f of c at c. Right, then function is continuous. And proof of this sequential criteria is exactly same as the proof of what we did for limit. Only f of c is replaced by L. And therefore, I will leave this as an exercise. But this is very important criteria and you should remember because proof is exactly similar to the proof that we discussed for limit. Right. And therefore, no need to discuss the proof again. But from this sequential criteria, we can understand many functions and their continuity. Right. So let f of x is equal to 1 if x is rational, 0 if x is irrational. Then question is discuss the continuity of f on R. That means at what point this function is continuous and at what points it is not continuous. So this is what we want to discuss. So first case, if A belongs to R and A is a rational number, right? Then question is A cluster point of domain of this function? Is A cluster point of domain of function? Yes. What do you think? The entire line is a domain and I have selected one point in the domain, right? So what to do? Is it a cluster point of R? Can
Yes,
you
sir.
see the figure? Do you see the figure? I have drawn a figure.
Yes, sir.
So A is a cluster point, right? Because if you draw any neighborhood around A, it overlaps with R. The answer is yes. And therefore, while talking about continue, should we discuss? Right? So does limit x tends to A f of x exist? Does this limit exist?
Yes, sir.
limit exists?
Yes, sir.
But we proved that the limit does not exist for this function. How? Does limit at a exist? What is the guarantee? See, sequential criteria. So note that a is rational. Therefore, what is f of a? What is value of function at a? What is value of function at a?
1.
1.
1. Now, the question is, the is limit x tends to a f of x is equal to 1, which is f of a. This is a question. Does the limit exist and is it same as value of function at a? Correct? What is the answer? And go back to the sequential criteria. What sequential criteria says, if you choose any sequence converging to C, f of x n must converge to f of C. So, is it true for any sequence? What does it mean if you have two sequences which converging to C, but f of xn and f of yn does not converge to the same number or f of C, then not continue, right? So let xn be a sequence of rational numbers with limit of xn is a, right? So let yn be a sequence of irrational numbers with limit of yn is a. Is it possible to have such sequences, first of all?
Yes, sir.
Right, there are many possible such sequences. So therefore, since xn is rational for all n, what is f of xn? What is the value of function at xn? 1 for all n. Therefore, what is limit n tends to infinity f of xn? Is
1.
1. Also, yn is irrational for all n. So what is limit n tends to infinity? So what is f of yn for all n?
0.
0, right? So therefore, what is limit n tends to infinity f of yn is 0. So what is the conclusion? Therefore, limit of xn is a and limit of yn is also a, but limit of f of xn is not same as limit of f of yn. And this is already discussed in the while talking about limit. What is the conclusion of this? The limit of this function at a does not exist, right? Because it is a cluster point. If point is a cluster point of domain, then we should take whether limit exists and limit is equal to value. So therefore, can I say that the f is not continuous at a?
Yes, sir.
Next, if a belongs to R is an irrational number, Suppose A is irrational number. Then by same logic, consider a sequence of rationals and irrationals and so on. Then limit x tends to a f x does not exist. Right? So you can check it with similar way. And therefore, what is the conclusion? Therefore,
Function
f
is
is
not continuous for any point in domain.
right at a. Hence, f is not continuous at a at any a in R. That means f is discontinuous everywhere. On R. So this function is discontinuous everywhere on R. Right? Therefore, this is a kind of very bad kind of function as far as continuity is concerned because everywhere discontinuous. So now if I define f of x, now I will define new function x if x is rational, 0 if x is irrational. Now geometrically f of x is equal to x and f of x is equal to 0. If x is rational, value of function is on this line, y is equal to x line, and if x is irrational, value of function is 0, means on y axis. And if you recall this, limit of f exists only at what point?
X equals 0.
X is equal to 0. Right, limit of this function exists only at 0. That is, what is limit x tends to 0 f of x? What do we expect here? What is it? Is 0.
0.
0.
And what is f of 0?
0.
0. Fine. So limit of function at 0 is 0, which is f of 0. And if a is not equal to 0, then limit x tends to a f of x does not exist. So if a is not equal to 0, then limit of this function at a does not exist. What is the conclusion of this? Therefore, f is continuous at 0 and f is discontinuous at a if a is not equal to 0. Correct? That is, this function is continuous only at x is equal to 0. So this is a function which is continuous exactly at one point. Right? It is very strange and we cannot see easily how the function can be continuous at exactly one point. But it is possible. Is it clear?
Yes, sir.
Yes.
Yes.
Now let f of x is equal to 1 minus x if x is rational and x if x is irrational. Right. Then what is limit? At what point this function limit exists first of all? So 1 minus x. So
X is equal to half.
x is equal to half. So this is line y is equal to 1 minus x and this is line y is equal to x. So if x is rational value is on the line y is equal to 1 minus x, So f of x lies on this line, x rational, and f of x lies on this line if x irrational, right? And where these two lines coincide, x is equal to half. So limit x tends to half f of x. And what is the limit at half? What is the corresponding point where these two
Half.
lines coincide? Half. And what is f of half? Half is rational. What is value of function at half?
1 minus
Is
x.
1 minus x. That means 1 minus half. It is half. Therefore, limit at half is same as value at half. Right? Can I say that? Therefore, f is continuous at half. Is it true?
Yes, sir.
But if
Yes, sir.
a is not equal to half, then limit x tends to a f of x does not exist. Right? So if a is not equal to half, then limit x tends to half f of x does not exist. X tends to a f of x does not exist. And therefore, can I say that f is discontinuous at a which is not equal to half? Right? So hence f is continuous only at f is continuous only at what point?
Half.
Only at half, and at all other points it is discontinuous. Right. Now give okay, let us see one more example. So let f of x is equal to x square minus 5x plus 6 if x is rational, 0 if x is irrational. Then at what point this function is continuous? For which f of x is continuous at x for which x square minus 5x plus 6 is equal to 0. That means these two coincides, value at rational and value at irrational coincides. That means x is equal to 2 and 3. Is it true? Do you understand what I am saying?
Yes, sir.
So f is
Yes, sir.
continuous. So this function is continuous. So f is continuous only at x is equal to 2 and 3. At all other points it is discontinuous. You can write down in detail. So it is continuous at 2, it is continuous at 3, and if x is not equal to 2 and 3, then it is discontinuous. So these things can be discussed. And therefore, give an example of a function which is continuous only at x is equal to 1, 2, 3. Can you produce such function?
Yes, sir.
Right. Of a function which is continuous only at 1 by 2, 1 by 3, 1 by 4, 1 by 5. So such examples certainly you can construct. It is possible. And At all other points discontinuous. Let f of x is equal to x sine 1 by x if x is not equal to 0, 0 if x is equal to 0. Now discuss continuity of f on R. To discuss the continuity of this function on R. How would you discuss? So first of all, if x is equal to 0, then what is limit x tends to 0 f of x? From our previous discussion, what is the limit of this function at 0?
0.
Either
0.
sandwich principle or any other technique, it is 0. And is it same as f of 0?
Yes,
Right?
sir.
Therefore, can I say that f is continuous at 0? Correct?
Yes, sir.
Now, you can give details. Why this limit is 0 and so limit exists. So that you should explain because we already spent some time on this. Right? Now, if x is not equal to or a is not equal to 0, then is f continuous at a? This is the question. Yes.
No, sir.
Why no? Okay. So note if f of x is equal to sine 1 by x, then limit x tends to 0, sine 1 by x does not exist. We already proved this, right? Correct?
Yes, sir.
So, okay, let us call this as gx. So, limit of this function does not exist at 0. But if a is not equal to 0, then limit x tends to a sine 1 by x exists. Right? Do you understand this? At other points, this limit exists. Problem is at 0 because 1 upon x tends to infinity as x tends to 0. But at other points, no problem at all. Right? Or probably that we'll discuss later on. Also, limit x tends to a sine x. If you think about sine x, this limit is sine a. Right? So why? That we'll discuss. But at present, you can believe this is sine a if point is not 0. With so that if you look at a not equal to 0, then limit x tends to a sine 1 by x exists. And what is this limit? Sine 1 by a. Right? Which is same as f of if you think about gx, so it is same as g of a. So can I say that can I say that can I say that g of x is equal to sine 1 by x is continuous at a not equal to 0? Can I say this?
Yes, sir.
Fine. Now, second point we should note, let hx is equal to x. Hx is equal to x. X belongs to R. then H is continuous on R. Is it true?
Yes, sir.
Because it is Fx is equal to x, it is continuous. And therefore, by our algebra of continuous function, therefore, f of x is equal to x. F of x is equal to x into sine 1 by x is equal to hx into gx. Is product continuous? At a not equal to 0? Yes,
Yes, sir.
because h is continuous everywhere. G is continuous at a non-zero, so product is, therefore h is continuous at a non-zero, so product is continuous. And therefore f of x is x sine 1 by x is continuous at non-zero. And already we discussed that it is continuous at 0 also. And therefore, what is the final conclusion? Thus, f is continuous everywhere on R. Yes. Is this correct?
Yes, sir.
Fine. So let f of x is equal to absolute value of x, right? Or it is same as x if x positive and minus x if x is negative. What is the graph? Do you remember graph? If x is positive, it is same as y is equal to x. If x is negative, it is y is equal to minus x. So this is the graph of this function. Question is f continuous at x is equal to 0? Is it continuous?
Yes, sir.
Yes, sir.
Right, because limit x tends to 0, f of x is 0 and f of 0 is 0. And you can check this limit, it is true. So as we discussed before, sum of two continuous functions is continuous. So let f of x is equal to a naught plus a1x plus an x to the power n. What is a0, a1, an are constants. So this is a polynomial. F is a polynomial function, you can say, right? So is f continuous
Yes, sir.
on R? Why?
We can first say that x is continuous on R. Therefore, x raised to any power is continuous. And so
Right,
multiplied by any constant, it is continuous and the sum is continuous.
right. So constant function is continuous, so a naught is continuous, a naught x is continuous, a naught x square, a1 x square is continuous, and so on. A n x raised to n is continuous, right? Any power of x, and we know that sum of continuous function is continuous, so this is continuous. So therefore, every polynomial function is continuous. Is on R everywhere. So polynomial functions are very nice functions that you can understand later on why these are nice, because they are continuous everywhere. But the basic question is, so let f of x is equal to what I should say, sin x. X belongs to R. Now the is f continuous. on R, and it is not easy to show, right? In fact, this question is relative, so it is easy or difficult. It is relative thing, but actually you prove that it is continuous using some properties of sine and cos, right? So note that for any real numbers x and y, uh, what is sine x minus sine y? Is it same as 2 times sine uh, of x minus y into cos of x plus y? Is it true? Up angle formula. You check this.
Yes, sir.
Yes,
It's
sir.
correct. So now, therefore, it is true for any x and y. Suppose if I take absolute value sin x minus sin y, then I will take absolute value of right hand side, right? So 2 times absolute value of sine of x minus y into absolute value of cos of x plus y. Fine. Now further, also note that absolute value of sin x is less than or equal to absolute value of x for every x in R. Why? Do you know this? Yes. Do you know this?
Yes, sir.
Because if you observe the geometry, so f of x, absolute value of x means this function, right? Then this is absolute value x function. And if you look at the graph of sine function, how is it? How is the graph of sine function? So this is a graph of sine function. And if you take absolute value of this is sine x, and what is the graph of absolute value of sine? Wherever it is negative, convert it into positive. Positive part as it is, but negative part becomes positive. Positive part as it is. Same on the negative side. See, so positive, negative part becomes positive if you take absolute value, and positive part as it is. So this is a graph of absolute value of sine x. And what is the graph of f of x is equal to absolute value of x? This, so absolute value x. The second figure is clear now.
Yes, sir.
And therefore, from the second figure, what do you observe? What do you observe? At any x, this is absolute value of sin x, and this is only absolute value of x, which quantity is smaller. Therefore, absolute value of sin x is less than or equal to absolute value of x for all x. So this is just from observation, but there are other ways to prove it. You can think about it, right? You should think about it how to explicitly prove it. The absolute value of sin x is less equal. This is exercise to prove that absolute value of sin x is less than or equal to absolute value of x. Right. We should think about it. But this is true. Therefore, from expression to above, what we will get from above to expression, what we will get absolute value of sin x minus sin y, which is 2 times absolute value of sin of half into x minus y into absolute value of cos of half x plus y, right? But now this is less than or equal to 2 as it is. Now absolute value of sine of something is less than or equal to what? And absolute value of cos is less than or equal to. Is it clear?
Yes, sir.
And therefore we get very interesting inequality. So sine x minus sine y is less than or equal to x minus y, or all xy. Whatever real number you select, this is true. Right, but our basic problem was sine x is continuous at any real number or not. So now let a belongs to R. Choose any real number. Right? Then what we want, limit x tends to a, sine x is equal to sine a, which is f of a. This is what we want. Now can you prove this? Can we prove this? How to prove this? Given epsilon, we want delta. Do you understand? And then from the previous inequality, can you produce delta? And what is a delta?
Yes.
Right? So what is delta? We want to prove that limit of sine at a is sine a, and but by previous it is less equal x minus a, right? And therefore what is a delta?
It can be epsilon.
Right, so choose delta is same as epsilon. Therefore uh, if distance between x and a is less than delta, then what is distance between sine x minus sine a, which is less than or equal to x minus a, but x minus a is already less than delta and delta is less than epsilon. Thus, for any a, limit x tends to a, sine x is equal to sine a, which is f of a, right? Therefore, f of x is equal to sine x is continuous at every x in R. Therefore, sine function is also nice function because it is continuous everywhere. So similarly, you prove that f of x is equal to cos x is continuous on R, continuous everywhere on R. By same logic, by same technique, you can prove it. Yes. So f of x is equal to exponential is continuous on R. So this is, see, basically proving that sin x, cos x, exponential x are continuous. So this is actually technically difficult. We are directly using the inequality, and so that we feel that it is easy. But uh, how to prove that inequality, again, difficult task. Similarly, exponential function is continuous. That is a difficult task. But note that so sin x, cos x, e to the x, log x are not algebraic functions. Algebraic functions means what? The polynomials or functions obtained by this polynomials are called as algebraic functions, are transcendental functions. Right, and therefore these functions, how these functions are obtained, how these functions are invented. So these functions are continuous by definition. That means how these functions are defined or developed, from that definition itself they are continuous. And to understand this, you need to learn more analysis, right? More real analysis needed. So, but you can believe that these functions are continuous and don't need, actually don't need proof. But if you are asked proof, the above is the proof for sin x or cos x you can have. But if you go deep into the conceptual things, then these functions are by definition they are continuous. Definition means how these functions are developed or invented or defined. Right? Okay, so I think our time is over. We'll stop here. If you have any doubt, you can ask. Yes. Any doubts?